Assalamualaikum to my beloved lecturer, Dr. Naziatul. I'm NURIN want to present about our business statistics case study. We get a special topic where we study the labor statistic for age 45 to 49 around year 1982 to 2019. So first of all, we like to thank to Dr. Naziatul for giving us opportunity to carry out this assignment study case. So for our case study, we need to arrange the data statistic for our special topic today. So let me explain about what is statistic. Statistic is a sign of data. Usually, the statistic is a sign of intelligent decision making in the face of uncertainty, and it used in many disciplines such as financial analysis, auditing, and so on. Actually, we have 6 objectives, and this is our objective for our case study. Next, we go to first objective with data arrangement. Data arrangement is sometimes data in rows and columns, so there are 3 types of tables can use to describe the data. First is frequency distribution. This is our data. So we go to step 1, which is identify K. So this is solution for search K. So we get K6, right? So go to step 2 and find the class width. This is class width we get. So our class width is 16. So step 3, we need to set the individual class limit. Step 4, we need to make tally based on data. Finally, step 5, we can build frequency distribution. So this is our frequency distribution. Next, second and third table, we need to identify relative distribution and cumulative distribution. So this is both a formula and table for relative and cumulative distribution. That's all from me. Next, we go to graphical method and AISHAH will present it.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURIN and my matrix number is H19E0380. And for this presentation, I would like to present about the graph. And based on our observations about the labor in Sarawak from age 45 to 49 through the year 1982 till 2019. So we choose to do the histogram and algebra graph. It is because since this data is a group data, so from our perspective and what we have searched about this, histogram and algebra is the most suitable graph that we can do, and really suitable to show the quantitative variable data. Okay, next we move on to the graph, and I would like to explain about the histogram graph first. And for this graph, we need to find the upper boundaries, lower boundaries, and also the midpoint. And this is the formula to build the histogram graph. And this is our histogram graph, and this is what our graph looks like. And for our graph, for the y-axis we use the frequency, and while for x-axis we use the midpoint. Okay, next we move on to the algebraic graph. And for algebraic graph, it also known as cumulative frequency graph. So to do this graph, we need to find the upper boundaries and also the cumulative frequency. Okay, and for algebraic, this is the formula to do the graph. And this is how our gift graph looks like. Well, for the gift graph, we use frequency as the y-axis, while for x-axis we use the upper boundaries. So we move on to measure of variance that will be presented by my lovely friend.
Right, now I will explain about measure of variation. Measure of variation used when we need to describe distribution of data. Measure of variation have a three type of them: range, variance, and standard deviation. So I will explain one by one. So let's check it out. Range is the data difference between maximum and minimum data entries in the set. You can see range equals to maximum data entry minus minimum data entry. So that is the formula. Range is the quite simple ones, so you can easy to find the range. The simple word is maximum data, the highest data, and the minimum as the lowest data. Number 2 is variance. So you can see the table, the complete table. If we want to find the variance, so the value of x, how we get that? Number of labor 36.5 plus 52.5 and divided by 2, so you can get 44.45. So x power of 2, the value of x power of 2, you can get 1975.80, and value of fx 7 multiplied by 44 and 45.45, you can get the value. So that is the also what we can say that the complicated the data, but it's okay if we know the formula, we can settle this problem. So we go through the formula. You can see that the formula from the table, you can fill into the formula and you can get the calculation. But remember, you need to find the value one by one, and finally you can get the value. Alright, last but not least is a standard deviation. That's also quite simple. You can see the formula. S equals to S power of 2. So if you press calculator 933.58, you can get 30.55 or 30550. The numbers 933.58 you can get from the variance. That's all from me. Thank you. Let's go to the another part.
Thanks, Mr. Rahman. Next, I would like to explain about measure of central tendencies. In this subtopic, we actually highlight four most important things, which is central tendency, mean, mode, and median. Central tendency is a value that represents the center of distribution. Usually, there are three common use to measure tendency, which is mean, mode, and median. Based on our case study, we more focus in group data. So we go to the mean. This is mean formula. Mean is sum of fx divided by n. This is group data for our case study. We can see where f, x and sum of fx, and this is our solution of calculate mean. So our mean is this. Next, this is median formula, and this is our frequency distribution of our table label of Sarawak. So for median, first step we need to determine the location of median class. So our sample is 36. We need to divide it 2, so we get 18. Then we focus to cumulative frequency. In this table, 18 is around 16 and 22. Automatic, we take this for our class median. Second step is search lower class boundaries. We got two formula, this and this, and we get this. Step 3, find class wide. Our class wide is 16. Step 4, find this. So to find this, you can see at the table, for the yellow, this, for the blue, this. Finally, calculate using median formula. Our median is this. Next, this is mode formula. This is our frequency distribution. To find mode, first step, determine location model class based on higher frequency. Focus to frequency. The higher frequency is 10, so automatically we choose this as model class. Second, determine lower class boundaries. Use two formula and we get this. Step 3, find class wide. Our class wide is 16. Step 4, find triangle 1 and triangle 2. To find triangle 1, 10 must be minus 4, so we get 6. For triangle 2, you see after 10 is does not have number, right? So 10 minus 0, so we get 10. Last, calculate mode based on mode formula, and this is our mode. That's all for me, and I want to invite Mr. ADHAM for measure of position. Welcome, ADHAM.
Assalamualaikum, my name is Muhammad Adham bin Azhar. Today I want to talk about measure of position. Measure of position is a method by which the position that a particular data value has within a given data set can be identified as with other type of measures. There is more than one approach of defining such a measure to determine the measurement of position. The data must be sorted from lowest to highest. The different measures of position are 1. Quartiles. Quartiles is divide the data set into 4 equal parts. Second, deciles. Deciles is divide the data set into 10 equal parts. And third, percentiles. Percentiles is divide the data set into 100 equal parts. The first quartile, Q1 is a value is the data set that 25% of the value fall below Q1 and 75% of the values fall above Q1. The second quartile, Q2 is a value in the data set that 50% of the value fall below quarter 1 and 50% of the value fall above quarter 2. The third quartile, quarter 3 is a value in the data set that 75% of the values fall below Q3 and 25% of value fall above Q3. So for the interquartile, range is the difference between the upper and lower quartile. Okay, let me show you the calculation. In conclusion, we use some methods such as data arrangement, graphical method, measure of center tendency, measure of variation, and measure of position to calculate the data of the labour force of Sarawak. number by age 45 to 49. As a first step to arrange the data, given we use frequency distribution to calculate the number of classes, which is seed class interval or class width, which 16 and the class limits. Other than that, relative frequency distribution and cumulative frequency distribution are also used to arrange the data.
Last but not least, this is our shape of distribution. From our case study, we see this is our mean, mode and median, and we see where the error. So for our shape of distribution in this case study is square to the left.
Thanks.